Hello, welcome back. I'm sure you've taken like a bad photo like this before, and then when you go to edit the image, you play with like increasing the brightness, you increase the contrast, and you might have even played with something called the saturation. But what exactly does it mean to make an image more colorful? In this video, I wanted to find out what exactly is happening to the colors themselves when we increase or decrease the saturation in an image. It turns out that saturation actually has two interrelated meanings. You can define how saturated an individual color is, and you can also define the global saturation level of an entire image. So I'm first going to show what happens to individual colors as we increase that saturation slider, and then we can kind of use this as a framework to create totally new color sliders. So I made one called extreme saturation that actually allows you to make images that are more colorful than most software even allows. The second one I made is called Hue Rotation, and it shifts the colors in really fun, unpredictable ways. In terms of data, an image is defined by these three layers, these three two-dimensional arrays called the red, green, and blue channels. And at each pixel, you have three values, the red, green, and blue values, which are between 0 and 1. And those three numbers define the coordinates in the red, green, and blue color space. So here you can see that each pixel is represented by a point. Natural images are going to have some type of distribution in this red, green, blue color space. And so what happens when you decrease the saturation to a minimum? All the colors will fall onto this line that runs from pure black to pure white. On that line, the red, green, and blue values are all equal. So that is our first clue as to what saturation is doing. But to see it more clearly, it helps to use a noise image. I sampled all pixels uniformly at random inside the RGB space, and that gets you an image that looks like this. Increasing saturation pushes points away from this line. It kind of pushes them towards the corners of the color space. If we want to understand this further, it really helps to go to a different color space entirely, one that has saturation actually built in as one of the coordinates. In this video, I'm going to focus on HSL because that's what Premiere Pro uses. HSL stands for hue, saturation, and lightness. These three values basically define a cylindrical coordinate system where the hue is like the polar angle, the saturation corresponds to the radius, and the lightness corresponds to the z-axis. It turns out that you can actually transform the RGB space directly into the HSL space. You take the RGB space, tilt it on its corner, that line of the neutral colors becomes the z-axis. Then we kind of project the other corners onto a hexagon, and you then stretch out the top and bottom, and that gives you the HSL color space. So now when we increase the saturation, we see that all points still move away from that grayscale line. However, now that just means moving out in the radial direction. On iPhone, they have something called vibrance. Vibrance is like similar to saturation, but like something is different, right? It's not making it colorful in the same way somehow. I wanted to like examine the difference between saturation and vibrance. And one way to do that is like take some of these random pixels, look at how their saturation, their pixel level saturation value increases as a function of the global saturation slider. As you increase the saturation or the vibrance, you get this very non-intuitive like function where the pixel level saturation increases in this really weird way. I can tell by looking at that graph that something really complex is going on, that I'm not even gonna try to reverse that. I did use this as inspiration to create a totally new color slider, which I called extreme saturation. This slider is motivated by the fact that the pixel level saturations are not not all of them are reaching up to the max, right? Some of them are still kind of not fully on the surface of that cylinder. I'll put the actual expressions I used here if you want to pause it, but the idea is just that for every pixel, this function will increase its saturation to the absolute max. Taking our noise image, we can increase its extreme saturation to the max. Voila, we have the most colorful image that's ever been made. Now on to color rotation. What if we just rotate these pixels in the HSL space so that the hue is changing? I tried it on this picture of fruit. It just so happens that this picture of fruit lies in a very narrow pie slice of the hue wheel. The effect is more impressive when you actually have an image that has colors that are spread out. It's just cool, just something interesting, like to make you think about color differently. And how do you know that someone else isn't seeing like a hue shifted version, like a hue rotated version of reality? The way that your friend sees the world, they could see red as blue and blue as red. You know what I mean? So that hue rotation is kind of like allowing you to see the world from someone else's perspective potentially, you know, I don't know. Thanks for stopping by and having an interest in this project. Hope you enjoyed. See you next time. Peace.